Hello again everyone, welcome back to ptet.chemistry channel. So this is work 5, the last work associated with this rate of reaction topic for the combined science 14 to 16 years old chemistry content. So this combined science is basically a combination of 3 natural science in one subject, and as such the contents covered within are a bit more introductory as compared to a pure science or pure chemistry content. In this question, we have hydrogen peroxide given the formula of H2O2. The 2 at the bottom here refers to the hydrogen. The 2 on this bottom right refers to the oxygen. So there are 2 hydrogen atoms and 2 oxygen atoms. And hydrogen peroxide decomposes to give you water and oxygen. I can write an equation for it. This will be water, H2O. Oxygen exists as a diatomic molecule. So these are straight from your Year 9 combined science curriculum, where you know oxygen has 6 valence electrons, 6 electrons in the outermost shell. It uses 2 for sharing to the 2 hydrogens, forming 1 covalent bond and 2 covalent bonds, and you still have 4 more electrons in the outer shell for oxygen. For water essentially, okay? For the oxygen molecule, however, so each of them will share 2 electrons with another oxygen atom, but just like any group 6 elements, it only uses 2 out of the 6 valence electrons for forming covalent bond. So you still have 4 more electrons on each atom of the group 6 oxygen, such that you get a double covalent bond O2 there, whereas this is H2O. This equation is not balanced. To balance the equation, I need to balance the atom on the left and on the right. So this will give me 2 there, and this will be 2. Because there's 2 times 2, there's 4 hydrogens. 2 times 2 is 4 hydrogens. 2 times 2 is 4 oxygens. You have 2 times 1, which is 2 oxygens. And 2 times 1, which is another 2 oxygen. Total on the right hand side, 4 oxygens. Total on the left hand side, 4 oxygens. State the total number of atoms in one molecule of H2O2. So here you have 2 hydrogen atoms, and then here you have 2 times oxygen atoms. So they want how many atoms are there altogether. There are 4, because 2 atoms plus 2 atoms give you 4 atoms. Now they want you to show the chemical symbols of the elements in a molecule of water. So there's H2O, oxygen in the middle. Hydrogen and hydrogen, they are bonded to the oxygen, just like what I've drawn earlier. I'm just translating that into the correct dot and cross here. Oxygen form 1 covalent bond to the hydrogen there, because hydrogen already has 1 electron. They just need to share 1 other electron from the oxygen. So same thing with the other hydrogen, because we have 2 hydrogen bonded to 1 oxygen. If I use cross for the oxygen, oxygen is in group 6, so 2 6 electronic configurations. Even Year 9 combined science students will be able to tell you that. 2 electrons maximum in the first shell. You go to the second shell, which is period number 2 in the periodic table, and you have 6 electrons because it is group 6 element. So you have 6 outer shell electrons. Of course, you only use 2 out of 6 for forming covalent bond here, for sharing here. So 6 minus 2, you still have 4 more. So 1, 2, 3, 4. That was what I had drawn earlier. That was what I explained earlier. I've just reiterated, I've just refreshed myself in explaining this question here. The next thing, the decomposition of hydrogen peroxide is carried out in the presence of a catalyst. This is a term that we came across when we did rate of reactions. So catalysts speed up the rate of reactions. So the purpose, what is the objective? What is the use? What is the purpose of adding a catalyst? So a catalyst speed up the rate of reaction. It makes the reaction goes faster. Okay, it makes the reaction go faster by speeding up the rate of reaction here. The next one, the solid compound manganese dioxide. Manganese is an element in the periodic table. In the middle of your periodic table, the first row is got manganese Mn. It's bonded to 2 oxygens. You use it as a catalyst. What name is given to the family of metals which contain manganese? So this is the middle block. This is the middle block of the periodic table. So the middle block of the periodic table is a topic that will come across later on in year 10, if not in year 11. They are called transition metal. So this family of metals in the middle block of the periodic table, of which manganese is one in there, is called transition metal. Hydrogen peroxide contains two non-metallic elements. The key word there really is non-metals. Non-metals and non-metal, they form bonds, they form covalent bonds by sharing electrons. So non-metals don't like to transfer electron by losing or gaining. Instead, they share electrons. So the type of chemical bond, name it, is going to be covalent bonding or covalent bond. So covalent bonds involve sharing of electrons between nonmetals and nonmetals. Hydrogen peroxide, hydrogen and oxygen given earlier in the question, H2O2. Hydrogen and oxygen, both of them are nonmetals that form covalent bond by sharing electrons there. The next bit of this question, so this is the apparatus setup. This is the manganese dioxide, so that is the catalyst. Remember the definition of a catalyst. It is not used up in a reaction. It's not used up in the reaction at all. You simply speed up the rate of reactions. The hydrogen peroxide is your H2O2 and they will decompose to give you oxygen gas. So oxygen gas is being collected in this measuring cylinder here. As you collect the gas, the level of water inside will drop down because the gas particles are pushing onto the walls of this container as well as on the surface of the liquid water, and they will push the water level down. And these are lines on the measuring cylinder that enables you to read the volume of the oxygen being produced. So the student measured the time for a known volume of oxygen gas to collect. So measure the time. So this is what you measure. So what we measure is what you call a dependent variable. Dependent variable is what you measure. And you can relate the time there to rate of reaction because rate is related to 1/time. The shorter the time, the faster is the rate. The longer the time, the slower is the rate. 1 divided by longer time, smaller rate. 1 divided by smaller time, faster rate. So what are you changing here? We are not told what we are changing here anyway. So there are 4 experiments so far. And the volume of oxygen gas collected is 40. And the time taken to collect this particular volume is whatever stated there. So of course you can relate that to rate. So rate is going to be 1/time, as you had seen in a couple of other work before this. State and explain. So there are 2 bits to this question. Which one the reaction rate was the highest? Well, I'm going to explain first. So I'm going to do part 2 first. So rate is equal to 1/time. So the shorter the time, so the shortest time taken, which is 10 seconds, 10 seconds, as I've seen here, 10 seconds is the shortest time out of all this time, will give the fastest rate because the smaller the time, 1 divided by smaller will give you a bigger value. So they will give you the fastest rate or the highest value for the rate, and therefore I need to state which experiment A, B, C, or D. So after I explain, then I state it. So 15 seconds there, 1/15 will give you, sorry, not 15 seconds, 1/10 seconds will give you the highest rate, that is experiment C. So experiment C is the fastest experiment out of all of them, okay? Out of 4 experiments here. State and explain. So again, number 1 and number 2, state and explain in terms of particles. So this is in terms of particles. One variable or one factor could have changed in order to obtain the results. So you want to obtain the result as shown here. What could you have changed to obtain these different results? There are many things you could have done here, but all of them require the use of catalyst, so you don't want to change the catalyst. The catalyst have surface area, so you could have said you change the surface area of the catalyst. You could have changed the concentration of the hydrogen peroxide solutions. You could have changed the temperature of the solution as well. So you learn a couple of factors. So factors affecting rate. Factors that could affect the rate of reactions include, number 1, temperature. As temperature increases, you know rate will increase. We saw that different time taken to collect this particular volume of gas, and therefore they could give us different time, and therefore they will give us different rate. So rate could change as temperature changes. you could change surface area. So our reactant is not solid, but our catalyst is solid. So you could have a lumpy manganese dioxide catalyst, or you could have a powdered form of the catalyst. So all of them require the use of catalyst, right? So I'm not going to involve a catalyst here. I could also change concentration. So your solution is hydrogen peroxide. So concentration of the hydrogen peroxide solution, when that increase, red will increase as well. Okay, so let's start explaining. I could have used any of these factors, but I've got to explain it. So I'm just going to state, let's say number 1, temperature. So when I use temperature, how can I get my answer? So I can say as temperature increases, what will happen to the particle? As temperature increases, particles, or the reacting particles, will have more kinetic energy. So we talk about movement related to kinetic energy as well as temperature. That was from year 9 states of matter, the very first topic that even lower secondary science students will have learned. Particles have more kinetic energies, they move faster, they collide more frequently, and they collide more frequently, then this will give you a faster rate of reaction. You get more effective collision. Let me spell that properly. More effective collisions. So faster rate of reaction. Of course, you could also use any of these factors. If you use, for example, concentration of the H2O2 solutions. So concentration of the H2O2, the formula of which was given at the beginning of the question. So you don't even need to know the chemistry because it was given in the question if you can read, okay? If you can read the question. So when the concentration increases, so concentration means how much of it you have per unit volume. When concentration increases, we have more particles per unit volume. Therefore, they collide more frequently. I should really move up a little bit so that I have a bit more space. Collide more frequently. And when they collide more frequently, rate increases as well. So, okay, so hopefully that makes sense there. Let me just move that over there. Okay, so it could be that, it could also be the surface area of the catalyst, as your reactants here are actually hydrogen peroxide and the catalyst is not a reactant, but you could change the surface area of the catalyst, and a finely powdered catalyst will obviously give you a faster rate of reaction compared to a catalyzed reaction using a lumpy form of the catalyst. Okay, on to the next question. So this student investigate the effect of changing acid concentration. This is actually a different question. This is question number 2, let's say. Effect of changing acid concentrations on the rate of reaction. This is between hydrochloric acid and calcium carbonate. Based on our previous work, you should know how to write word equations. Word equation means just use word. Metal carbonate plus acid will give you metal salt. So what you get is calcium chloride, that is your metal salt. And then you also get carbon dioxide gas, and that is presumably what you're collecting here. You also get water. This is a gas, but what we're doing here is we use the same volume of the HCl, and then same mass of the powdered calcium carbonate. We use powdered, not lumpy. So greater surface area, because powdered one would have greater contact area between the calcium carbonate and the acid. So this student measured the volume of HCl. I don't think you would need too much of these 0.2 mole per dm cube. It's just concentration. So these are just concentrations. So they are unit of concentrations. What you did back in year 9, in your syllabus, you learn about gram per dm cube. So this is called mass concentration. You can think of this mole per dm cube as something which is very similar to mass concentration. That was what you did in year 9. That is in your syllabus. As you can see, this concentration changes from 0.2 to 0.5 to 1.0, 2.0, and 2.5 mole per dm cube. Different concentrations will affect rate of reaction. as concentration increase, you have more particles per unit volume. They can collide more frequently because you have more particles per unit volume, colliding more frequently, faster rate of reaction. Complete this diagram in order to show collecting and measuring the volume of gas. This gas is your CO2 gas as stated in this equation between a metal carbonate and an acid here. So you want to show a gas syringe. So a gas syringe is what you use in order to collect gases. So I need to label. This is a gas syringe. A gas syringe has lines because these are graduations, or these are lines on the gas syringe that allow you to read the volume of the gas. This is a piston. The gas produced will push against the piston and start pushing it away such that whatever volume reading you read on this reading will tell you the volume of the gas there. This is sealed, so the gas will not escape from there. Instead, it will just get into the gas syringe. This is the labeling part of this apparatus. They are very, very important. And of course, we can just say carbon dioxide gas collected inside. Carbon dioxide gas collected inside there. Okay. The next part of this question, calculate the average or the mean volume. So this is a lower secondary mathematics. How do you do averaging? You do two different experiments, so you repeat it and you get results which might or might not be the same. And what you're doing is averaging. So what we're doing is we add them together. Use a bracket because that is what your calculator and primary school mathematics taught you to do. When you do averaging, you add them up together first. You do them first, that's why I put a bracket first. And then I divide by 2 because I have 2 different readings. So do that on your calculator. 5 plus 7 in a bracket, I get 12. 12 divided by 2, I get 6. And the next one I will get 13 plus 14, use bracket and then divided by 2. 13 plus 14, 27 divided by 2, I get 13.5. They did not say how many decimal place or or what, so I just write down whatever value I have from my calculator. The next one, 29 plus 27 over 2, I get 28. And then the next one, 53 plus 56, don't forget your bracket. 109 divided by 2, I get 54.5. And last but not least, because this is only 1 mark, so this should be 1 minute for your 1 mark question. So 66 plus 64 divided by 2, I get 63 there. Now state which concentrations of the acid produce the fastest rate of reaction. So we know that rate is equal to 1 over time. So if we want the fastest, so that means the rate is the highest. And if you want the rate to be the highest, you need the time to be the smallest. Because there's just mathematics. Smallest time means the shortest time taken for the reaction. That's why it's very, very fast. Use the data to justify. So you got to provide data from this table. So this table gives you the average volume of gas produced. So they don't give you time. They have a fixed time here. You see? Fixed time. But the one they give you a lot of gas in the same time, that's going to be the fastest rate of reaction. That has got to be 2.5 mole per dm cube. I'm just reading the unit, 2.5 mole per dm cube. That is the concentration just by reading the table without even knowing what this mole per dm cube actually mean, apart from the idea that it's a concentration. Now, what's data showing us that? Actually, I was wrong. Am I wrong? No, I am correct because it's the shortest time. But then we are not looking at time, we're looking at a fixed time, and which one produced the largest volume of gas. This is a volume of gas. The one that produced a lot of gas, the largest volume of gas, at this concentration, the largest volume of gas is being produced. It produces the most, or you can say largest volume of gas, which was, use the data, right? 63 cm cube of gas, which is carbon dioxide, in 2 minutes. Use data. So I'm just writing down the data that I have. The most or the largest volume of gas there. Now there is a piece of equipment not mentioned in the method, but you need it. You need it to carry out rate of reaction experiment. So just now, remember you saw this in 2 minutes. How are you going to record the 2 minutes if you don't have this piece of equipment? So it's very important that you have something called stopwatch. As you have seen in the other work, sometimes they use stop clock in the name or in the method itself, in the instruction given, but stopwatch is typically what you have learned in physics as well. Next one, the student measures the volume of hydrochloric acid using a measuring cylinder. What else could you use to measure the volume more accurately? This is in the year 9 titration bit of the syllabus under reacting masses, where we cover concentrations. We also talk about reacting volume of solutions. So you have learned this thing called pipette, P-I-P-E-T-T-E. If you want, you can also spell it as volumetric pipette. If you don't believe me, you can go back to the year 9 lecture tutorials. You can go through the year 9 syllabus, the year 9 notes, and you will see that volumetric pipette is an apparatus that you need in order to measure volume more accurately. So the next bit suggests one factor not mentioned in the method, so not mentioned so far, must be kept constant. So this is what you call control variable. So control variable means it could affect what you're trying to investigate, but you don't want to change it. You must keep it constant. So what we're investigating here is the changing the concentration of the hydrochloric acid. What else did they say? They mentioned that the mass of the calcium carbonate, here is the same volume of hydrochloric acid, the same mass of powdered calcium carbonate. They mentioned powder already, so we can't change the surface area, we can't change the mass of that, but they did not say anything about temperature. This is about concentration. Changing concentration means you don't want to change temperature. They did not mention about same temperature. So temperature must be the other factor that is not mentioned so far, but it could affect the rate of this reaction. As you know, as temperature increases, rate of reaction increases as well. Explain why. Why do you repeat the experiment for each concentration? So that to ensure reliability. So to get reliable result. Because when you do it 2 times, you can be sure that the results are reproducible, reliable results that can be reproduced. So that means someone else, when they repeat the experiment, they should get similar kind of result as you, provided that they're doing everything the same as you. Okay. One of the products of the reaction is a gas. So state the name of the gas. As we mentioned earlier, this was a metal plus acid reaction. Metal carbonate, calcium carbonate plus hydrochloric acid will give you calcium chloride as your metal salt, carbon dioxide gas and water. Metal carbonate plus acid give you carbon dioxide gas. Just like the previous question, when we have carbon dioxide gas, they want the name. If they want the name, not the formula, when you give the formula, you don't get any mark because it shows that you don't know how to read the question. Carbon dioxide, to confirm its identity, we need to include the result of the test there. Okay, so we bubble or we pass the gas. So we pass the carbon dioxide collected through lime water. Lime water is basically calcium hydroxide. It was in the previous work or the previous question in this paper. We should have gone through corrections on that actually. So bubble or pass the gas through lime water. Lime water turns cloudy, or you can say milky. Precipitate means solid. That is because the product, which is calcium carbonate, so lime water, which is calcium hydroxide, plus your carbon dioxide will give you calcium carbonate, which is insoluble in water. So this is the product. Calcium carbonate is insoluble in water. That is why you get this cloudy or milky precipitate to confirm that carbon dioxide is present. The actual result, use lime water. Lime water give you cloudy or milky solid, which is a precipitate there. Okay, so that's the end of this work 4 tutorial, a bit long because there were 2 full questions. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel and follow me at ptet.chemistry on Facebook, Instagram, Twitter and Telegram to get connected. I'll see you in the next tutorial video.